now that you've tried some of these questions on your own, let's take up a couple of these. So in this one, we have 5 to the power of 3 times 5 to the power of 4. Now, because we're multiplying two powers with the same base, we're going to use the product rule. The product rule says that we rewrite the base and we can add the exponents. So for this one, we have 5 to the 7. Part B, 5 to the power of 4 divided by 5 to the power of 2. We're dividing powers with the same base, so that means we need to use the quotient rule. We're going to rewrite the base and subtract our exponents. Okay, part C and part D. These two questions are slightly trickier because the base is not just a 5. Part C says negative 5 to the power 3 times 5 to the negative 3. Right now, they're two different bases, so I can't combine them using any exponent rules. But we could split negative 5 to the power of 3 up so that we could have negative 5 cubed as negative 1 cubed times 5 cubed. So let me rewrite that in the long form. Negative 5 inside my bracket can be rewritten as negative 1 times positive 5. Now, all of that is raised to the power of 3. And the second part of my question, I still have 5 to the power of negative 3. I'm going to use the product rule now to distribute the 3 to each of the bases. So I would have negative 1 to the power of 3 times 5 to the 3 times 5 to the negative 3. And this 5 to the negative 3, I just copied from the line above. So I'm going to continue to simplify. These two have the same bases, so I'm able to use the product rule to simplify. Okay, so let's simplify the exponent here. I'm going to rewrite the negative 1 all to the power of 3, and now I have 5 to the power of 3 minus 3, so 5 to the power of 0. 5 to the power of 0 is equal to positive 1. Negative 1 to the power of 3 is a negative 1. So now I have negative 1 times positive 1. And the final answer would be negative 1. Right, part D. This one, once again, is slightly different. I have negative 5 to the power of 6. But since this negative 5 doesn't have a bracket, I know that the exponent is only applied to the 5. It isn't applied to the negative sign. So I could rewrite it as negative 1 times 5 to the power of 6 times 5 to the power of 7, and all divided by 5 to the power of 3 raised to the power of 3. So now that I've written it slightly differently, I see that I've got 3 powers with the base 5 that I can combine all together. Now remember, if we're solving a question that has a fraction, We need to solve the numerator as far as we can and the denominator as far as we can before we combine the two. So in the numerator, I'm going to leave the -1, and then I'm going to combine these two powers using the product rule, and I have 5 to the 13. I've added our two exponents. In the base, I have 5 to the power of 3, all raised to the power of 3. So that would give us 5 to the power of 9 using the power rule. Okay, continuing on. These two have the same bases, so I'm going to use the quotient rule and I'll subtract the two exponents. So 5 to the 13 minus 9, and that gives us 5 to the 4. Okay, so that's our final answer. We could write it like that, or we could say -5 to the power of 4. Both of these are the same because without the bracket, the exponent 4 is not applied to the negative. Okay, our next slide, we're going to put all of the rules together and simplify these complex expressions. I want you to express it as a power with a positive exponent. Okay, let's look at this question. I have 4x negative 3 y7 times -x to the power of -2, y to the power of -5, all multiplied to 3xy to the power of 3. Now, this -x is a bit curious because without the bracket, this -2 is only applied to the x. So I'm going to rewrite this expression as -1 times x -2 y -5. So I've just rewritten it. It's exactly the same, but this negative becomes very apparent to me that it's not part of the x. Instead, this is a coefficient. Coefficient is the number that you multiply your variables with. So we have three coefficients, 4, -1, and +3. Bases, we have two bases, x and y. So first, let's treat our coefficients like we do with regular numbers. And since it says we're multiplying, we're going to multiply all our coefficients together. 4 times -1 times +3. So we have -12. Next, we're going to deal with our base x. We know that all of it has to be done by the product rule because all of these are multiplying together. So the first one that I have, -1 plus -2 plus 1. So the x here has no exponent, but the implied exponent is a 1. Then we have our y's. Y to the power of 7 plus -5 plus +3. Let's collect all the like terms in our exponent. We have -12, x to the power of -4, and y to the power of 5. We're not quite finished yet because we've been asked to express it as a power with a positive exponent. -4 is not a negative, sorry, is not a positive experience. Negative 4 is a negative power. So we're going to use our negative exponent rule to put it into the reciprocal. This is in the numerator right now, so it's going to be thrown down into the bottom as the denominator. I have negative 12 y to the power of 5 divided by x to the power of 4. Part B, we have the expression negative 2m squared n to the power of negative 3, all raised to the power of negative 5. We're going to use the power rule here and the distributive property. So we've got multiple bases inside our bracket and the negative 5, and the negative 5 is going to be applied to every single base in the bracket. So the first base that we have, negative 2, negative 2 to the power of negative 5. Second base that we have m to the power of 2, but it's 2 times negative 5, so m to the power of negative 10. And finally, we have n to the power of negative 3 times negative 5. So that's n to the power of 15. Let's rearrange this so that all of the negative exponents are in the reciprocal. So these are currently in the numerator, and they're going to go into the denominator now. Only thing left in the numerator, n to the power of 15. And underneath, we have negative 2 to the power of positive 5 and m to the power of 10. Part C. The expression is 2y to the power of 4 times 8y to the negative 12, all divided by 4y squared to the power of negative 3. Here's a little note. Coefficients, they can be expressed as powers. So 2, 8, and 4 are our coefficients. We can simplify it the same way we did here, but because I notice that all of these are part of a power with a base 2, I can convert it and then simplify it using our exponent rules. So 2 is equal to 2 to the power of 1. 8 is equal to 2 to the power of 3. And 4 is equal to 2 to the power of 2. Now I'm just going to rewrite this expression with these coefficients in power form so that I can simplify it as using my exponent rules. 2 y to the 4 times 2 to the 3 y to the power of negative 12 divided by 2 to the power of 2 y to the power of 2 all to the power of negative 3. Okay, so I'm going to use my product rule to simplify the numerator, use my power rule to simplify the denominator, and then simplify the numerator and denominator together. Okay, so our three bases, we have 2 and y. Sorry, only two bases. Right, the first one in the numerator, the power rule, I have 2 to the power of 1 times 2 to the power of 3. That gives us 2 to the power of 4. The next one, y to the power of 4 times y to the power of negative 8. 4 plus negative 12 gives us negative 8. In the denominator, we're going to use the power rule to distribute the negative 3 into all the bases. So we have 2 to the negative 6 y to the power of negative 6. Now let's simplify this by using the quotient rule. Quotient rule says that I'm going to take my exponents and subtract them. So we have 2 to the power of 4 minus 6, and y to the power of negative 8 minus 6. Right, let's simplify it. 2 to the power of 10, because our two negatives become positive. And now the y, negative 8 plus 6, that gives us negative 2. And we need to put this into our denominator so that we can express it as a positive exponent. 2 to the power of 10, all divided by y squared.